In today's wars, the sound of tanks and gunfire is slowly being replaced by the buzz of unmanned drones. From silent killers in the sky to AI-powered surveillance swarms, drones are redefining warfare and costing billions to defend against weapons that cost only thousands. Drone warfare involves using unmanned aerial vehicles, UAVs, for military operations, from targeted strikes to surveillance, recon, logistics, and jamming enemy tech. Drones reduce soldier casualties, provide real-time intelligence, and make it easier for smaller countries or non-state actors to wage asymmetric war. A brief history, how it all started. 2001 to 2010s, U.S. deploys Predator drones in Afghanistan and Iraq. 2010s, precision strikes increase, sparking ethical debates. 2020s, Turkey's Bayraktar TB2 and Iran's Shahed drones change the battlefield in Ukraine, Syria, Ethiopia, and Gaza. Types of military drones today: combat drones, surveillance drones, swarm drones for coordinated AI micro-drone attacks, radar-evading stealth drones, nano drones, which are palm-sized drones for room clearing and recon, Kamikaze/suicide drones, Excuvid, Shahed 136. FPV drones. How the Shahed 136 Kamikaze drone is used. Built by Iran and deployed by Russia in Ukraine, the Shahed 136 is a low-cost, one-way attack drone. Function. It carries an explosive warhead and is designed to crash into targets. Cost. Estimated between $20,000 and $50,000 per unit. Tactics. Russia launches Shahed drones in swarms to overwhelm Ukraine's air defense systems. Their goal is to damage critical infrastructure, command centers, and radar installations. Modern militaries have developed layered defense systems to counter drone threats. Some are lasers. High-energy beams, like Israel's Iron Beam, destroy drones in flight. Jammers. These devices scramble drone communications or GPS to knock them off course. Interceptors. Missiles like the Stunner Interceptor are launched to shoot down incoming drones. Microwaves. Directed energy fries onboard drone electronics. Nets and guns. Physical countermeasures for small drones in close range. Real-world example. In 2023, Israel deployed Iron Beam laser systems to neutralize hostile drones during border skirmishes, with great success. Cheap drones versus expensive defense. Asymmetrical warfare. This new battlefield has introduced a painful economic paradox. Stopping cheap drones with high-cost systems is unsustainable, which is why cheaper, energy-based defenses are now critical. The ongoing conflict between Iran and Israel highlights one of the clearest examples of asymmetrical warfare in modern military history, particularly in drone technology. Iran's low-cost offense, Shahed 136 and other Kamikaze drones. Iran has produced thousands of low-cost drones, estimated $20,000 to $50,000 each. These drones are often launched in swarms, targeting infrastructure, air bases, and radar installations. Tactics used. Iran uses proxies, like Hezbollah or militias in Syria or Iraq, to launch these drones, creating distance and ambiguity from direct confrontation. Israel responds with Iron Dome interceptors, $40,000 to $100,000 per shot, and is now deploying Iron Beam lasers, a few dollars per shot. Stunner missiles, part of David's sling, and radar networks are used to counter long-range drone and missile threats. In 2023, Israel reportedly intercepted multiple Iranian-origin drones using advanced electronic warfare and lasers. Economic imbalance. Iran can launch 10 to 20 drones for the cost of a single Israeli interceptor. This cost disparity creates pressure on Israel's defense systems and military budgets, a key trait of asymmetrical warfare. Key point. Iran uses cheap, mass-produced drones to exhaust and penetrate Israel's expensive, high-tech defenses, shifting the nature of the conflict from traditional military clashes to economic and strategic attrition via technology. Ethical and legal considerations. Ethics. There's growing concern about AI making lethal decisions without human input. Civilians. When drones miss or malfunction, innocent lives are at risk, often without accountability.
Military startups powering drone warfare in Ukraine and the US. New defense tech companies are shaping modern battlefields with smarter, more accessible drones. Shahed AI. Founded in 2015, Shield AI develops autonomous drones like the Nova, used by US forces. These drones navigate indoor and GPS-denied spaces using advanced artificial intelligence. Aerodrone. This Ukrainian startup focuses on cargo drones. The D-80 Discovery delivers supplies across long distances to frontline troops, making logistics safer and faster.
How drones are fueling a defense startup boom. The Ukraine conflict has become a real-time test lab for drone technology. Startups iterate fast, learning directly from battlefield feedback. Nations like Israel, the US, and several in Europe are investing billions to stay ahead of the low-cost drone wave being produced by Iran and others. Let's look at some drones using fiber-optic guidance. Some drones, particularly in Iran's arsenal, are now using fiber-optic cables for navigation and control. Instead of relying on satellite signals like GPS, these drones trail a thin fiber-optic wire that allows real-time communication between the operator and the drone, even in areas where GPS is jammed or spoofed. Key benefits: immune to GPS jamming and electronic warfare. Extremely difficult to detect by radar or signal intelligence. Allows precise, mid-flight control, especially for one-way kamikaze missions. Example: Iran's Shahed 136 and some variants are suspected of using a fiber-optic spool in early flight stages to maintain guidance in heavily contested airspace before switching to autonomous mode. This development is forcing advanced militaries to rethink how they detect and disrupt drones that don't rely on traditional radio frequencies.
In addition, let's look at drones powered by Starlink. Satellite-connected warfare. One of the game changers in modern drone warfare is the use of Starlink satellite internet for real-time control, communication, and coordination. Starlink, developed by SpaceX, provides low-latency, high-speed internet through a constellation of thousands of low Earth orbit satellites. This allows drones to operate in remote or jammed areas, transmit live HD video feeds and sensor data back to operators, coordinate multi-drone missions over vast distances. Real-world use. Ukraine's military has integrated Starlink with various UAVs, allowing operators to command drones far beyond line of sight or traditional radio range. Some Ukrainian units have modified commercial drones or battlefield recon drones to stream live data via Starlink terminals, even while mobile. This tech gives smaller forces advanced capabilities, once reserved for major powers, proving that connectivity is now as critical as firepower.
The future of drone warfare. AI will power aerial dogfights without human pilots. Urban drones will navigate tunnels, buildings, and sewer systems. Kill decisions may soon be made entirely by algorithms. Drones will battle each other as aerial supremacy becomes automated. Conclusion. The war of the future is already here, and it's silent, fast, and airborne. While Iran floods the skies with $20,000 drones, nations like Israel and the US scramble to stop them with billion-dollar shields. The world's balance of power may no longer lie in nuclear stockpiles, but in silicon, sensors, and swarms.